Really fun. It's really nice to see so many people join from so many different locations. So that's really perfect. So yeah, and let's get started on the first evening of Printfest. So my whole goal for this week is to that are new to printing to kind of take a deep dive into what printing is and what you can do with it for footwear in our specific case. Um, I want to also hear from you guys, from hey Matt, from everybody that's in the audience to see what you guys are doing and experience that you have. Because I know, especially in our event in Footwearwise, it's always so nice to have the community there and people can talk directly, but not everybody can join physically. So I was like, it's also nice to have community gatherings online. So that's also what this is for. So this is informal. So if you have a question, by all means, open your mic and ask me or raise your hand. All different options are fine. If I'm sharing my screen, I might not see the raised hand. So you're always welcome to just open your mic and ask me. I am here tonight, who would like to show already as introduced to all of you. Let me see if I can turn it a little bit. You can come sit next to me. I can come sit next to you. So this is Nela Coronel, and maybe you would like to introduce yourself. Nela is our new full-time employee in Footwearology. So together we are working daily in the new print lab that you see behind me. But maybe you want to introduce yourself a bit because I think the audience doesn't know you yet.
Of course. Thank you, Nico. Hello, everybody. My name is Nela Coronel, as Nico mentioned. I'm from Colombia. I'm a multidisciplinary designer with background specifically in architecture. So I'm really passionate about 3D printing. It's been a great journey so far, and really excited for this new.
Yeah, so Nela joined our lab when we were still a few months ago when we were still in Barcelona for a very interesting project that she's also going to show you today because that's a really interesting one for materials. And yeah, turned out that she was a perfect match. Loves printing, is not afraid to take the printer apart, put it back together, change heads, do maintenance, because that's all the stuff that we have to also do. Many of you who print a lot will know that this is something that needs to happen. So this is something that I was really happy with. And obviously for here, since we are now, we're still in Spain, we are in Alicante. We moved from Barcelona to Alicante to be closer to the factories, and Nela joined me. And so it's also very practical that I then have somebody bilingual in English and in Spanish because my Spanish is still a work in progress. I understand a lot, but fluent speaking is not the case yet, but working on that hard. But and also for those of you who might be interested in that, I think we have a very multicultural audience tonight. We will also be starting Spanish language printing courses. So because I know that there's also an audience that does not speak English fluently, so that will also be coming for a lot of other courses. But what I wanted to do today is to talk about printing materials. Can I ask in the audience? You're just welcome to speak or otherwise type in the chat whatever you feel most comfortable with. What experience you guys have with materials in printing? So what do you do at the moment? You're also welcome to just open your mic and talk as you wish. Just to test the waters a little bit to see where everybody's at. I'll open my chat window also to see.
Hello, this is Mitch from North
Hi,
Chicago,
Mitch.
Illinois.
Hi.
Hi there.
Hi there, Mitch. Yeah.
Very interested in the whole process. I'm currently using Feel-A-Flex Foamy
Yep.
for printing shoes,
Right.
and that's my primary material for now because I feel like I need to be at least that soft so that the shoes feel good.
Yeah. Yeah. And what are you printing with Foamy?
Right now, just a slip-on shoe. It's it's like a flat bottom, barefoot, wide toe box, barefoot style shoe.
Yeah, barefoot is great for printing because, of course, it's fast. If you have a minimal shoe, then so there's a few new materials that are on the market that we will also talk to you about today, and could also be interesting maybe for those of you that are interested to go a bit deeper materials to also have a look at some of the pellet materials, because besides filaments, we are also printing with pellets. So that could also pellets like granulate. So that could also be interesting maybe for some of you to hear. Anybody else want to share? Yeah, tell me, Mitchell.
I'd like to mention that I'm trying to print the shoe with support material, with PVA support material.
Yes. Yes.
And if I have to skip like 10 layers of support material, I'm printing with the TPU, the foaming TPU.
Yeah.
And if I have to skip a bunch of layers of the support material, then when my Bambu Lab H2D comes back and starts to try and print the support material, it seems like either it doesn't stick good to the top of the TPU or it clogs the nozzle with this PVA.
Yeah. So have you ever tried to simply make the filaments fully of PLA? The supports fully of PLA rather than PVA?
Yes, and my PLA is not sticking to the top of the Feel-Flex foaming.
Right, but technically it's also not necessarily supposed to stick. It's just supposed to support. But does your model come loose from the support?
The PLA strings on top of the TPU. It's like there's not even a weak bond. It just strings back and forth. And
I'm not fully understanding how your support material is on top of your TPU and not under your TPU.
Well, I'm trying to support the opening of the shoe that has like a solid like rod around the opening, like a round rod around the opening of the shoe. And so I'm using support material to come up when I'm printing flat, both on the inside of the upper, and also to support that little round ring around the opening of the shoe. I need to put my support material on top of the sole that's already printed. You see,
you are printing an upper on top of a sole that is already printed. You're also always welcome to either share your screen so that we can see maybe in the slicing, or send me your model.
Sure.
That counts for all of you, by the way. If you have specific indeed material questions or issues that you come into, more than happy to answer that during these classes, because that's also what this is for really people who are like, I'm a bit stuck because I'm trying to do A, B, or C, and I can't get it done.
Sure. Let's see if I can
have it handy, because then you're welcome to share your screen.
Okay, here we go.
Absolute beginner.
My first time.
1 second, Mitchell. So, oh gosh. Okay, there I have loads of remarks already. For anybody in the audience at the moment, if there's anybody who's absolute beginner, please just let me know, because of course we're now doing headfirst into a printing problem. If this is new to you, then don't worry, we will start after this more from the beginning. There are 2 people raising their hands. Is that a question on this specifically, or a question for later? Michael, and who else did I see raise a hand? I saw some raised hand mentions, but
whoops, I don't know. Can you see my screen?
Yeah, see your screen.
Okay.
Okay, novice. Okay, perfect. So I hear some people indeed novice. Okay, so for those of you novice, hang in there. We are okay. Brian also new. Perfect. No worries. So have a look at what he's showing, but if it's already a bit much for you, don't worry, because after this we're going to start a little bit more from the beginning. But Mitch, take us through what we're looking at here, because this is your shoe.
Yes, so this is my shoe. Let's see, I can show you what the STL looks like. This is what it looks like before the support material.
Right.
And I'm printing, this is a separate little plate that I'm printing on top of the sole. There's the sole on the bottom. I'm
Okay.
printing this so that the support material has better surface area to stick to. So that's a separate plate. You can see, I
Yeah.
call it a PVA plate here.
Yeah, I understand that, but it's just the way you do that is going to result in so much support material. How long is your entire print for this both? Because you're doing it in two parts, as I understand it. You're going to first make a sole, and then on top of that, you print the upper.
Yes, it's one day, 4 hours,
Oh yeah.
39 seconds.
Is it just for prototyping, or are you looking to create something that is commercial?
It's currently in the prototype stage, to go to commercial, but you can see there's the support material being printed. And so there's the opening that I'm talking about there that I need it for. And so this plate here, this bottom yellow, the yellow is the support.
Yeah, I understand.
That sticks to the bed beautifully. And then I print the sole on top of it. So that's a raft to give myself a good.
So, but the PVA, so on the bottom, you also have PVA for support. Is that correct? Yeah.
Yeah, so that's because I want to try and capture, I want a nice smooth transition on the curvature of the heel.
Okay. So I have a few elements of advice. So, and that's also maybe interesting already for the people who are a bit more novice. So when we're looking at this print, you have the black parts, which are the actual shoe. And then the limey yellow parts, greenish parts that are support materials. The strategy that we have at Footwearology at all times is to design a shoe in such a way that you have very minimal, if any, support material. And the reason why we do that is to bring down printing time, because the longer it takes to print your shoe, the harder it becomes to make it commercial, because you are now doing on one printer, one shoe, one full day, so 24 hours and some more. For a barefoot shoe, this is too long. So when you are looking, for instance, I don't know if you've ever followed the people from Fused, FUSED in Hong Kong, also printing a barefoot shoe, 3 hours. So
wow.
3 hours.
That would be beautiful. That's
there's
beautiful.
a lot to win here. So what you have to ask yourself, would you mind grabbing me the shoe that's up there? What you have to ask yourself when it comes to the design, is it necessary that you have the thick piping on the top so that you have support all the way around the instep? Because I'm assuming that this support that you have now is there because this piping, essentially this edge that you have on the instep, is an overhang, so it comes to the side and printer cannot print in the air. So is there not another way you can do that? And then also what you could think about is when you do the design of your front part, I'm showing you here an example of the first 3D printed shoes that came to the market already in 2014-15. This is from Feets in San Diego at the time. What they did was printing the upper and printing the sole separately and then fusing it together with heat. That's also an option, but you don't necessarily have to do that because it's extra work. They also had piping. I don't know if you can see, but this is because in the upper they stitched in a fabric lining. What many people don't know is that printed material you can also stitch. I mean, it's not so that everything has to be printed. But the trick was the curvature that they made here is kind of like a 45 degree. And this allowed them to print this upper without any support material underneath. The reason why you have so much support material is that your front goes basically up and then full horizontal. And that means that you have 100% overhang and that everything will be filled with support. And then in your case, you have to make it with dissolvable, because if you print this indeed with a non-dissolvable support, it's going to take forever to rip it out. And then it's also a bit of a shame to have a barefoot shoe with support material under, because the barefoot shoe can be fully flat. A trick that I'd like to give to you all, which will, if you do insist that you still want to have some type of heel and toe spring, is, oh, let me admit some other people. Let me see, is there other questions? That if you want some heel and toe spring, you print your model completely flat. Flat, 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 flat. Nothing underneath, no support, no nothing. Say that you are about half a centimeter, so I don't know how much of an inch that is from my heart. A fifth? No, a little bit less. Then what you do is you flip up the toe and flip up the heel off the build plate intentionally, and it will warp automatically into a beautiful heel and toe spring without any support whatsoever, because this is going to take you very long. And also what you see here in your screenshot is that, of course, since you have to print double material, you have a big purge tower. So the big cylinder that we see here in the middle, that is because if your printer goes from one material to the other material, it starts purging. So it means I'm printing with one material, and then if I go to the other material, I first print a little bit with that. So those are things that you could avoid. I think in the design that you have, it should be possible, largely, especially in terms of curvature, to eliminate all supports. And the top material that you have here, is that, how thick is it and what material are you using now? You said foamy, right? But are you using foamy 78 or foamy 95?
It's I think they call it Fielaflex foamy, and I think it's 78.
That's
It gets down to 60 if it's fully foamed with the right temperature.
Yeah. So it's
two millimeters thick. You asked.
And that's thin. So that's already also because of that. You should not be having a lot of support in there, because if you need to take that out, you might rip the material apart. So I would still love, I mean, if you would like to, we can have a look at your model, send us your 3D. I think that we should be able to slice with very minimal support. Do you have other options? Anything you want to say?
The angle, and also, of course, is because if the materials are different, the chemical properties, they are not going to touch together, and the third part is not going to bring the others.
This is indeed, because I now understand what your issue is, because you have kind of like a sandwich of support. So you have support bottom, then TPU, then support again, then TPU again. And this is also very expensive, because the reason why I was asking, do you use PLA, is that, for instance, if we're looking at brands that use dissolvable, what is usually the dissolvable materials, A, quite expensive, and B, it takes quite a bit to soak. So I hear a lot of people go like, I use dissolvable. You have to understand that dissolvable doesn't mean rinsable. So a lot of people think I just hold it under the tap and it's going to be gone. No. This has to sometimes for several hours soak in water. And then especially if you have a shoe, which is, for instance, open-walled or textile-like, it sucks itself full of water, and you also have to dry. So in our case, whenever possible, design around PVA. You can use it, but minimal. So I don't know if you've seen maybe some pictures of Zellerfeld, how they print. They have indeed layers of PLA. Then they only have the interface between the PLA support and the shoe of a PVA, because then you also save a lot of time and a lot of cost, because with PLA you can print quickly. It's a rigid material. Then you have a little layer of the dissolvable, and then you have your final shoe. But in your case, with a barefoot shoe, your entire goal of your design should be supportless, without zero.
I agree. But this shoe is not even really feasible at this point, because every time I use the PVA to print this yellow plate that you see the first layer of here, it starts stringing.
Yeah.
It does not lay on top of the TPU. And
You have
I know it's dry. I know it's dry.
So it's goo. So it's a gooey material. I don't know if any of the other ones. Also, people, if you have suggestions here, this is a community meeting. Feel free to pitch in. If you are saying, I think you should do this or that. I know we have some more experienced printers in here as well. But it's a great example maybe to start with, because I think indeed for the novices who are like, whoa, what am I even looking at? We jump straight into the discussion, which is essential for materials, is indeed what material am I using? How can I design my shoe for minimal material? That's something that we feel very strongly about. And what support material am I using? And how can I design in such a way that we have minimal support? Especially tomorrow when we are looking at the design for 3D, that's not going to be a 3D modeling class. Those we have separate classes for, but it's going to be a really good class looking at all kinds of 3D designs. How are they made? How can we improve them so that they have minimal support? So, and I think this is a great example of how you try to get to something workable, but in the end, you get so far away from what your original goal should be, because in my opinion, if we do some minor tweaks to the model, because your model is not so different from this model. So, and this had zero support inside, absolute zero. And
Well, that
it's
would be
purely
wonderful.
because of the angle.
That would be wonderful. Okay, I'm
Yeah.
glad I can show an example of what not to do.
Yeah. Thank you so much for sharing, and also for everybody else. If there's anything you guys want to share, we're just here to learn from each other, and we're here to share experience. So I'm really glad that Mitch shared this, because then we can help. But yeah, thank you for sharing, Mitch, and I'll jump a little bit back to the beginning of materials, so that we also have people who are new can understand a little bit, because now we've already covered actually a lot of ground that is quite new for people that are new to printing. So essentially, when we are printing a shoe, in the case of Footwearology and the people that are in our courses, what are we talking about? We are talking about printers that work with an extrusion system. We call it FDM, filament deposit model. I think if I'm
Here's the
Fuse deposit model, that's it. You can also call it FFF. People ask, what's the difference? There's no difference. It's more that in the beginning of FDM printing, there were two different brands that were dominating the market, and one was calling it FDM and the other was calling it FFF, and it's the exact same thing. So what is the whole idea of it? You have a roll of filament, so it's like a shoelace type material. It's a roll of plastic. This is a plastic that can melt. It goes inside the extruder, inside the nozzle. The nozzle also has a certain size. So it's important, something that we will learn also in this class on material, is the relationship between how big is my nozzle, how big is the hole that this needs to come out of, and the properties of my material, and what my end shoe might look like. But I'll get to that in a bit. So this goes inside your printer, it gets melted. Usually the materials that we use for the shoe itself, so not for support, but for the shoe itself, are around between 210 and 260 degrees Celsius, depending on what it is that you work with. And then you build it up layer by layer. It's always how I explain it to beginners. It's like icing a cake. So I know we have many males in the in the class. I don't know if you guys ice cakes, but if you make a cake, it's a very simple principle. Also, layer by layer by layer. And what is also similar to that is that the printer cannot print in the sky. So I always say to people, I'll go stand. If I stand like this, you know, I'm a bit big for the image. If I stand like this with my arms down, you can print me just in one go. As soon as I stick my arm out like this, and the printer prints my body, and it then needs to start printing the arm, there needs to be something under here. Because if the nozzle goes to the side and material comes out, if there's nothing here, it will fall straight down to the build plate. And this is why we need support material. And it's another thing that we are then trying to prevent in our designs, that we have these things sticking out unless it's absolutely necessary for our design or the function of our shoe. So what we just saw with Mitch is that he has around the instep something similar to this, but printed. This was stitched in, but printed. So you can then imagine that if you get here, either on the outside or on the inside, if that material goes sideways, that the printer wants to make support there to hold that up. So, and if it's really essential for your design, then do it. But in most cases, I would say design it out, because you don't have to do that. You know, if I make something, the more horizontal it is, the more overhang you have. And if you make something circular, already like this, then the printer usually can cover it. So this is something for you to understand. When we are printing something, you usually have a material for the shoe itself and the material for the support, if you have support. Usually the ambition is, at least in our case, and also in our courses, to not have support if we don't have to. So then what is the material that we are printing with? There we have a lot of different options. In general, in our case, so it's footwear. So we are using flexible materials. And with flexible materials comes a whole new world of printing, because what you have to realize is that most printers, say 90% of printers on the market, are made for rigid materials. So I know that, for instance, a lot of you guys might have a bamboo printer. We also saw Mitch now printing on the bamboo lab printer. Really great printer, can do multi-material, but not so much flexible. So the flexible does not come out of their material station. Why not? Because it pulls it way too hard. The issue that you have with flexible material is that it's stretchy, usually. That's also what you want for your shoe. But that means that as your printer starts pulling the filament in, what you want is that it pulls it down, but that it doesn't stretch, and then, you know, suddenly the pressure drops. So, and that's what happens a lot. Those of you that are experienced in printing know that the main issue is your tension, is how do I get it to continually extrude at the same pace without the filament just stretching. Suddenly it's stopping to extrude after a few layers. All these things are really specific to printing with flexible. It also means that if you print with flexible, you need to have a machine which is a direct drive. What is that? That is a machine that pulls the filament into the print head. So if you have the print head, or that the filament comes out of, you want the motor to be on top of that with the gears, so that it pulls the filament directly into the print head. The opposite of that is a Bowden tube machine. An automaker, for instance, most automakers are Bowden tube machines. That means that the filament comes from the back, through a tube, into the top, but the motors are on the back or on the side of the printer. Those printers are great printers for rigid material. If you want to print shoe lasts or anything, perfect. Get a machine like that. What is the advantage? Is that because the motors are in the back and not on top of the print head, that the print head is much lighter and can move way faster. That's why they do it that way. But for us, with flexible, if I have to push, it's like pushing spaghetti to a tube, you know, through a tube. If I have to push my flexible material all the way through this and then into the print head, forget it. It's not going to come out. Maybe with some, we call it semi-flex or quite rigid, little bit flexible materials, but not with the ones that we want to print with for comfort. So this is really important, that if you have that, look for that first. Also, if you are a beginner, by all means, please do not sweat out over a multi-nozzle machine. Start with your single nozzle machine. Because I think what a lot of people forget is that the difference is, say I'm printing a shoe and I want it to be, say I have a Zellerfeld, for instance, here, and I want it to be a bit stiffer here and a bit softer here in the upper. That is not necessarily done with different materials. This is one material. All the shoes from Zellerfeld are one material only, the shoe itself. So they have other materials for the support, but the shoe itself is one material. Same here for, this is from Fused, also all one material. So why is that? Because we will see in the class about slicing that the way we structure the shoe and how we make the inside of the shoe. So here you see an inside, the heel parts of a shoe. Here you see this grid on the inside. This is what we will talk about with slicing. This determines how hard or soft your shoe is, not just the material as such. So, and if you want to have the shoe a bit stiffer here and a bit softer there, then this is usually what you play with. The idea is not so much to right away put a ton of different materials in. You also have to realize, as soon as you try to do different materials at the same time, not only do you need to have a printer that can handle that, but also if you have a single nozzle printer and you simply change the material halfway through, which you can do, it all costs extra time. So for things that you do for yourself, prototypes that you make at home, no problem at all. If that print takes 2 days, you will knock yourself out. But if you want to do something commercial and you want to be able to produce that shoe or have that shoe made in series, absolutely not advisable to have shoes that are indeed over a day in printing. If you can prevent it, I always say, if you can prevent the multi-material, do it. So I know within the printing world, of course, there's a new gadget coming out all the time and people are like, whoa, so they could do this or that. We are now waiting for a new printer that I'm happy to show you guys. It does not arrive yet this week. I hope next week, from Korea, that has 6 nozzles. And of course, I'm excited for this one. And this is specific for flexible material. It's meant for really soft filaments. So we are very excited to go test it. We are testing it for FootRise. But even then, when I think of 6 different materials, I think maybe of doing a textile, almost like an embroidery machine. Not necessarily of doing a full shoe with 6 materials. Can do, of course, not a problem, can do. But there is a question, there's a can do, and there's a should I do a question. So this is always something that's also something we'll talk about tomorrow when we talk about the actual designing of shoes and how to do that. That there's the can I and the should I, and those are not always the same things in this case. Another important thing that I want people to understand, there's 2 important things that I want to emphasize before I talk a little bit, maybe the different types of materials, and then give the word to Nela also to present her project. First of all is the hardness of the filament. You might have already heard me ask Mitch, like, hey, are you a 78A or a 95A? And people who are new to printing are like, what? So this is this is Shore value. That means hardness. Those of you that are working in the footwear industry and maybe are used to working with foams will probably still know this terminology, because this is not just specific to printing, it's specific to plastics. So it's just the hardness of a plastic. So you have D values and A values. In our case, since we use flexible, it's mainly A values. And then the simple rule is, the higher the number, so the number is between 0 and 100, essentially. And the higher the number, the stiffer the material, the lower the number, the softer the material. So for instance, we have, do I have something really rigid here? Yeah, these ones, yeah. So here I have a filament, we like this a lot, just to show you a fun one, it's a rainbow filament. This is from Esun. Esun is a really nice, you write it like this, Esun. It's a Chinese supplier, I must say, has very nice filaments. What I like especially about these, they're very transparent. So if you're looking for something really transparent or metallic-y, definitely try that. We also see here a pink one. Here you see the metallic-y sheen, maybe a bit better. You have similar ones now from a brand called G-Tech. G-Tech with several E's. These ones are what we call semi-flex, meaning that they are 95A. So this is flexible, but fairly stiff. So if I make a full shoe of this, it is a bit rigid. Would you mind maybe getting the shoes from the window that are in there? Then I can then make you hear what it sounds like if you print a full shoe. Now, of course, the lower you go, the softer the material gets. So when we're talking about filaments that you can use, you have a very large category TPUs that are 95A. If you go on Amazon and you look for printing TPU filaments and they don't mention a number, you can count on it 95A. That's usually the standard, but it's fairly stiff. I would not always recommend. You can also go around 85 to 82. So for instance, here I have some, yeah, this is for instance a shoe from the filament, the eSun filament. This one we printed with a double nozzle, so a transparent outer wall and then an infill of another color, but I don't know if you can hear it. This is, yes, it bends, but it's fairly stiff. So this is made to my foot, to my size. So for me, it's fine, but I would not recommend this necessarily for a shoe. What you can also look at is stiffness that are indeed a little bit like 85, 82. This is what we use a lot for most shoes. So I have here, I mean, you can also combine. We have here a midsole. That's, oh, there's James is going to come to the call. Great. So here we have, for instance, a Filaflex, and this is an 82A. So this is definitely softer than we have. I already heard Mitch, of course, mentioning Filaflex. This is also for us still the filament that we work with most because it's very suitable for footwear. It's very soft. They also have softer varieties. So I also have here Filaflex 70A. So this is lower, quite a lot lower. It's 12 lower. You can already, I don't know if you can see it in what I'm doing here, but it's, this is very stretchy. And you have even lower, which is the 60A. So this is really like an elastic. Now, the problem is, usually when people start printing, they want to go straight for this really soft material because they think, yeah, the softer the better. For the upper, maybe yes. For the sole, by the way, no. So for the sole, I do not suggest to go 60 or 70, way too soft. Good rule of thumb. If you can, so say you have this, right? So we are testing now an infill for a shoe. Say I can do this if I push something completely flat, easily with my hands, that is not comfortable, that is too soft. So because the problem usually is that people touch the material and test the material with their hands, but you wear it with your feet, your whole body weight is going to be on there. If I can squeeze it flat with my hands, my body weight is going to push it flat instantly. So you, and there is definitely a thing as too soft. So don't sweat out when you, especially not when you're starting over, I need to go down immediately to 70 or 68. Why would you not do that? Because you also have to understand the softer the material is, the slower you have to print because of the tension issue that I mentioned before. You're trying to pull this literal elastic material through your nozzle, and it basically, the faster you print, the harder the material has to be pulled inside, the more it starts stretching. You'll have tension issues and your printer will stop extruding. Let's be honest, we are very experienced printers here at Footwearology, and we hardly ever use 60A because we cannot get it out of most machines. So this is really something to understand. Also to understand that using such a soft material on a filament machine will double your printing time. So is it worthwhile? A thing that you can indeed consider, which is also why we have the textiles course, because for textiles you could do it because it might only be a few layers, is that you start designing, we will talk about that tomorrow, shoes. This might be a bit of a strange model for you to look at, but that you start making modular ones. So you have a sole that is 3D printed and maybe an upper that you print flat. All these things are also possible. We look more at that tomorrow, and then maybe you could use much softer. If you insist on soft, so you want to indeed be around 60A or maybe lower even, then for sure switch to pellet printing. So for those of you that are experienced printers, go to a pellet machine. What are pellets? These. So hope you can see, this is just granulate. So this is a 60A, this is a 55A. You can go down as low as like 20A, but then you're basically printing a gel. You have to think about the lower you go. So we have a great pellet machine here by, one is by Direct3D. They print all kinds of pellets, and they, for instance, also make silicone breast implants with the machine. You know, it's really, really so. That's not necessary for us. Maybe if you do insoles and you want specific gel pads, maybe I do know an insole manufacturer with gel pads that goes down to 20, but not for a whole shoe. But I can show you here. I have one. This is indeed a 55A, and it's indeed, it feels even gel-like. It's extremely soft. We think it's nice maybe for certain cushioning, not necessarily for your whole shoe, or if you do it, maybe for the top of your shoe. But the good thing about pellets is that in the industry, when we make plastics, they are made with pellets. So you are able to get a lot more different plastics as pellets than you can get as filaments. Now, one thing that is important, I think, to mention, because we heard Mitch also talking about it, he said foamy. We have foaming filaments now. What does that mean? I think we have one, not that you see so much in the roll, but do we have a foamy lying around? Ah, we have a shoe. So, this, by the way, is a shoe that we dialed with textile dye, just to experiment. You can do that. This is one super soft and lightweight. So what happens is, of course, in the shoe industry, we see more and more ultra lightweight shoes because of the foams that we are using. And a foam has air inside. That's why it's so lightweight. So filament producers started producing foaming filaments. So you have, for instance, VarioSure, that is from Colorfab. Then we have indeed Foamy, which is from Filaflex. So how does that work? It simply means that if you are printing, you want to do two things with these filaments. And this is a mistake that some people make. First of all, you have to print high temperature because you want to heat them up so that they start getting bubbles. And you want to bring down the flow. What is that? Flow is how fast the machine extrudes. So how much material does it push through? You want to turn it down. The standard is 100%. You just go like, just flow. What you want to do is to bring down the flow to 60%, 70 tops in your slicer software. I can show later in the week how you do that. And that means that if you have the nozzle, so this little opening that the material comes through, that the material does not fully fill the opening so that it can expand and pull, suck the air in, basically, and come out as a foaming. The higher you go in the temperature and the lower you go in your flow, the more it starts foaming, and you have to find your ideal balance so that it still extrudes and is smooth and is very foamy, but does not get holes or whatever. So usually on the website of Filaflex, you can find very detailed description of what you should do for this filament. And that's very essential because you can simply set the flow to 100 and you can do the temperature as you do other TPUs, which is usually a bit lower, 235, 240. But then you almost get a rigid filament out of it. So for those of you working with foamy, we have good experiences, especially if you're designing your shoes well to be flexible, to print it with the Foamy 95. Because I'll get to your question in a minute. Because the stiffer your filament is, the easier it is to print with it. And the softer your filament is, the slower you have to print. Tell me, what's your question?
Yeah, hi. Well, basically regarding the flow ratio, what's the difference between that and the volumetric speed? Are they different? So the maximum volumetric speed
of how much volume you push through. No, technically this is the same. It's just that if you look at volumetric speed, it's much more complex, I think, to estimate exactly how much you push through. So because flow is in the basic settings of any slicer, but also of any printer. Because one thing that I always advise people to do is that, okay, you do your settings in your slicer, but then look at what you are printing. You know, don't walk away and go like, okay, well, it should be fine because my settings are good. No, I mean, if you see that the printer is not extruding enough or too much, you adjust on the printer. So on the printer, you cannot adjust your volumetric speed. You can adjust your flow. So
Okay, thank you. And the other question is, you mentioned the Bamboo Lab H2D is not quite good with flexible material. So now my question is, because I'm printing, it's not for commercial, but I need people to wear it to test it. It's just like sort of a medical project. So people have to be able to wear it to test it. It doesn't matter to me much how long will it take to print. So which printer you think is the best for that function if the duration is not the issue, but the quality is an issue?
you want to have the best quality for what type of, so I didn't fully understand what type of product you are
Just basic.
making.
It's again, it's a shoe, but we were sort of doing small modification to fit some medical purposes, like for bunions and
This
for
is more in
hands,
orthopedic,
for example.
in
Yeah.
the orthopedic side. Yeah.
Yes.
They don't really, yeah.
So which printer would you recommend?
Which printer or which filament?
Which printer first, and then
I think at this moment, for a lot of people printing, I do recommend a lot the Bamboo, which I think is a very, but then the new one, the H2D, because it's a bit larger. Uh, we also do a lot here on the FL Sun, but that's a printer that's unfortunately being phased out, so I would not advise that right now. So I think user friendliness of the Bamboo is really high and print quality is high. The disadvantages are that it's much more difficult to change your nozzle. So, I mean, a machine standard comes with 0.4 nozzle. From a quality perspective, that is great. From a print speed perspective, it's not great. So you would rather have a slightly bigger nozzle so you can print a little bit faster. But my first point would be Bamboo. Then from there, in terms of material, then definitely go for from a quality perspective, I would go for a TPU and not a foamy, especially if you want to print the full shoe, including the bottom that people walk, that hits the street. Foamy is not strong enough. Neither I think Shore is also, in my opinion, not strong enough to really have high anti-abrasion, which the TPU has. So this is, for instance, a shoe from, this is full TPU one from Fused. This I've been wearing for more than 2 years, and look how great that sole still
what
looks.
material is this again? Which material?
This is a TPU. This is an 85A TPU, quite generic from a Chinese supplier. Fused has a slightly different strategy of printing. So their strategy is minimal material, so you don't make the upper sole so thick. It's basically just 2 walls. They don't have infill in there. They only have infill in here. It's made to print vertically, so you even have a design element, which is the logo that it stands on. And it's really designed to not have any issues with overhangs and whatever. The printer can do it. And this uses indeed a medium hardness, so it's not a super soft. It really depends on what you want. I personally think for the medical footwear, especially for the bottom, it's better to have it slightly stiffer than the really soft ones, because for your joints it's not necessarily the best solution.
Okay. I had a there was the when I print shoes, with the number of walls is the I'm using the Bamboo Lab H2D and I'm using the 0.8 millimeter nozzle.
Yeah.
Okay. But then if I put 1 or 2 walls, they become separate. The
Oh,
sort
yeah,
of the
elimination.
base.
What is your layer height?
It's 0.4. I can share my screen with you if you I can.
There's a
So
number
I
of,
can.
so for people
That's
who are
the
beginners. Yeah.
so that's my these are sort of my settings.
Mhm.
And I'm using the foamy TPU for this one, and I'm using PLA as a support. But you can see here that for the first layer, they comes, they don't come as a one solid. So I need to put many walls, then they become solid. But if I put one wall, they disintegrate. I'm not like very
You,
experienced in 3D printing, but I
yeah.
filled a lot, if that counts. And I'm not really sure what would be the best combination, because when I put many walls, it becomes hard. When I put less number of walls, the base, it does not, it becomes sort of disintegrated. It doesn't really sort of
Yeah.
You can see.
Yeah. Okay. So here we have a pro and a con of the Bamboo Lab. So the
Yeah.
Bamboo is a user-friendly machine. If it comes to more advanced slicing, then it's not the most ideal one because the Bamboo slicing software has a lot of options. It also has a lot of options not. So what I don't really understand is it looks to me in your design that your lines are already separated, that they don't connect anyway.
Because I did a cut. Maybe because maybe I did a cut to make it flat, like from the slicer itself.
I could not really see from the screen. You're welcome to send us your file to have a
Uh,
look. But
sure. Okay.
what the issue is, generally, if you are printing with 0.8 nozzle, um, the general rule of thumb, which is correct, what you're doing is that you take half of your nozzle size as your layer height. So how thick is each layer that you are printing with? And the reason technically why you are doing that is because technically I could also say, okay, I have 0.8 hole and I could get like a 0.8 string out of that. But then you get indeed really round layers like this, and it's like circle on circle on circle on top, and they have very little attachment here because it's kind of like this. So that's why when you print with a lower layer height, so half of it, you get them to stick a little bit better. For me, what I see on your screen looks more like I did not understand what you meant with the mini walls and other walls because it looks like in the slicing already the things are separate. So it looks
Yeah.
already like it does not touch. So there might be other issues, but I cannot see that from where I am here, that there is separation between the lines for other reasons having to do with infill, lack thereof. It looked to me not like a solid wall anyway. And then indeed, it's not strange that if you take it off the plate, that those layers come apart.
Okay.
So, but happy you can send us always your file that
Sure.
we have a look and
I
see
will.
what's happening. So,
Okay.
I saw that Daniel, in the meantime, had a question about which one is strong enough for an outsole. Several are. So I would usually advise for the outsole to not go super soft. So the ones from Pew that I have here don't use any separate material for an outsole. You don't necessarily need to do that. The main secret basically is indeed in how you set your walls, so the bottom layers here, and how you make the infill that is inside, that is underneath here. I would recommend indeed, if we're looking at TPUs, try and go for a TPU that's like an 85. Not so much 82, we would go 80, anywhere between 85 and 95. You can also try, which is also a fairly good one, a little bit stiffer, but great also for outsoles, is Resiplex, which is the recycled Filaflex material. This is a 98A because this is a mixture of a lot of waste material from Replius, from the producer of Filaflex, and they combine that and make it black. So that is something that you can take into account. Other option is, and that's the here. Oops. It's a nice bridge to the Balena, actually. It's Balena. Not this Balena is a fully compostable material. Not that I advise this for the outsole because it's very strong, because it's not. The only reason that I advise it is that the biggest issue that we have in our footwear industry when it comes to waste from usage of shoes is that we have a lot of microplastic waste from our soles, whether this is a rubber, a TPU, a TPR. I mean, all the plastics that we use in our shoes, of course, rub against the street, same as with car tires. And we don't see that, but it's a really large amount of microplastic waste. So when people come to me and go like, I want to improve something in the sustainability of my shoe. Is there a compostable one? Then I'm like, by all means, but start with your sole. Because if I have this against the streets, and this layer protects me from the rest of my TPU. That's of my non-compostable TPU that it's above. Then it helps a lot with not having the microplastic waste. So it's just then that indeed this will wear off. Not immediately, but it will wear off sooner than a TPU. So it's kind of what you want to achieve. But there's pros and cons. I can imagine for a consumer that they want it to last very long, and at the same time you could also explain, yeah, this is essentially much better for the environment. So we're now doing some experiments, or going to do some experiments with printing it on top of existing shoes, also non-printed shoes, to create a layer of Balena on the outside. Are there any other questions in the meantime? Because if you let me babble, I'll keep going. On materials things, or things that people didn't understand or ran into.
Piggyback on the outsole question.
Yeah.
So I've been working on a sole. So this I made out of Ninja Tech Cheetah, the 95A. Yeah, so I'm interested in doing like just soles because I like to do uppers with leather and fabrics, and like either glue or sew it on to the upper. So yeah, I'm kind of just trying to figure out what's the best sore hardness for a design like this, where I'm using like a gyroid geometry.
I think actually that you could go quite rigid there. We've done a project for a company that wanted to start making running shoes fully FDM printed with lattices.
Okay.
And initially he was also thinking we need to go soft. But then we saw indeed in terms of energy return, that was actually much better when it was harder, especially if you have like a gyroid or any other actual lattice structure where you have mechanical bounce essentially.
Yeah.
So I would definitely also for print speed, especially since you're doing lattices, see if you can stick at a 95.
Okay.
And
Yeah, I just felt like
also
this one
print way
specifically
faster.
felt a little too rigid,
Yeah.
at least when when
Yeah.
I'm standing on it. So it
Yeah.
could definitely hold up the weight, but I feel like there's not enough of a return.
So so it does hold up the weight, but it goes flat, you think? Or
No. It like almost doesn't flex. It doesn't
Right,
flex
okay.
much. Yeah.
Right. So, well, it's great that you bring this up, because what people also need to realize, and it's a good note that I will take for tomorrow, is that the solution might be not so much in changing the material, changing your lattice. Because this is what we tried also, where the good news is then actually that you can make your lattice much less dense.
Gotcha. Yeah.
Because
So lighten it up.
Yeah, lighten it up, because we've been printing lattices till we're blind in the face for this project. And we found indeed that, the advantage is if you make the lattice less dense, we did have a lot more bounce. It was still strong with the stiffer filament. You still had great energy return because the stiffer ones kept bouncing a bit better. The very soft ones, it feels comfy to the foot, but especially when it comes to maybe sports applications, it doesn't give a lot of energy return. So the solution could very well be that it's not so much the material to change, it's the lattice to change.
Okay.
So,
Yeah. I'll test that out.
Yeah, try that. And then always welcome to drop us a question. Diego,
Sure.
tell me.
Just a quick comment about the lattices. I was thinking that another factor to take into account is the density of the lattice, but also the thickness of the lattice.
Yeah.
Because if you can play with zones, where you need
Exactly.
Where do you need more support? Then it could be a thicker lattice, or vice versa. That's something to take into account.
Yeah, absolutely. You can also try, we have done a lot of good stuff for that with plugins like Sphyrene, for Rhino, other plugins that make lattices, where you indeed are able to make quick changes to indeed the thickness, because indeed, as Diego said, one part is how many lattices per whatever square inch do we have, but the other part is indeed how thick are they, and especially if you say we're going to take thickness a bit up, but we're going to take density quite a bit down, then you might have a very lightweight sole, faster print, great bounce, And if you can stick to your 95A, I would always do so because you can print so much faster. Because the harder my filament is, the easier it is for the machine to pull it through, and the faster I can print. So, and that's a great advantage also if you want to actually make stuff. Sphyrene we also like, which might be a good tip for you because you want to put uppers on, because it creates tunnels. And it's tunnels that you can take laces through. So we also used it for creating soles where we want to attach uppers to. And then
Sphyrene, you said?
Huh? Sphyrene, yes.
Sphyrene. Oh, yeah.
Sphyrene.
Yeah, I'm familiar. I think I did the.
Yeah, SPH Sphyrene.
I was on the beta for that.
Yeah. And this is kind of like a lattice creator that is very specific, minimal surface, essentially also minimal material. Right. And it creates tunnels. It was initially made also for powder printing, that you could take the powder easily out because it's all tunnels. But the advantage that we found as an extra perk for it is that if you can manipulate a little bit how the tunnels are placed, and then you can basically push laces or yarn or whichever through those tunnels to attach your upper, which is usually also quite an elegant solution. So you can try that, which is a little bit more difficult with the gyros.
Yeah. Okay. Thank you.
Daniel Moreira also has a question. Hi there.
Daniel from Brazil here.
Hi.
What is the capability of the FDM printers to print, for instance, sole with lattices?
To print what lattice?
Sole, outsole with lattice.
An outsole with lattice. And why would you want to have your outsole with a lattice?
Sorry?
The midsole? You want a midsole or an outsole?
The outsole, the midsole, pardon me, the midsole.
Yeah, because indeed, I mean, there is capacity, but it is not as powerful in lattice printing as a resin or a powder printer is. It's indeed so that if you want to specialize in lattices, then the advantage could be that a powder printer or a resin printer is a bit better at that. However, apart from it being way more expensive and much less sustainable, those materials, then you would rather look at FDM. There are a lot of different lattices that you can do for FDM, also a lot of gyroids. There are a lot of specific lattices that you can do for FDM. And I think that we haven't even scratched the surface of what we can do there, since so many of the sports companies that experiment with lattices immediately jumped to powder or resin. And I don't think it's necessary. So you have also a plugin from Aaron Porterfield. And you know the plugin Crystalline? Not very sure. There's a plugin from Aaron Porterfield for Rhino for making lattices, specific for FDM. Let me see if I can quickly Google that for you. Plugin for Rhino. Okay.
Crystalline?
Yeah, open source Crystalline. Yeah, Crystalline. That's it. Crystalline.
Okay.
I will post here an article about it in the chat. And this also has a lot of options for FDM specific lattices.
Okay.
Yeah.
Okay, thank you.
No. And that's for those of you who are beginner. A lattice is like this coral-like structure that we use either as an infill or as the way that we construct something. It mainly has to do with the mechanical properties that these structures have, but also for some other forms of printing, such as the powder and the resin. You also need those structures to make things lightweight and not weigh a ton if they come out of the machine. So, and there's a lot that we can do. We use it a lot, of course, for sports, mainly for sports purposes or comfort specific purposes.
Okay, thank you.
Welcome. Any other questions?
Will you be going over like recommended slicer settings in the next?
Yes, there's a slicing class. Yeah,
okay.
Yes, there's a slicing class.
Cool.
So in that sense, yes, I will. And also for that class, please indeed bring your specific questions. you can already send us in advance even. That also helps Nela and me to kind of prepare a little bit for those questions, because some of those might be a bit complex that I cannot see in 1 minute what you have to do. And also what I always say with Slicer questions is that the answer that we can give is a recommendation, but you will always have to try it for yourself, because indeed, depending on where you are, the humidity, the printer you use, whatever you use, the combination that you use. So what I will mainly try to do in the slicing class is to talk about a couple of key principles for flexible printing. So what do I do in my slicer? What are things that I really need to be mindful of? And things that I would like to prevent, and some tricks, like some tricks of how do I not make my support stick to my shoe, and stuff like that. So that's what we will be doing. Aratha, you have a question. Thanks, Anthony.
Hi, Nicole.
Hi,
Yeah.
hi.
Yeah, hi. Yeah, I'm Aratha. Then I was joined Footwear Rise last year, and then
Yes, I know. Yes.
Yeah, I practice in my design more, and then
Yes.
now I start slicing, and then
Yeah.
I start see the problem of my design. So can I share my screen now?
Yeah, sure.
Yeah, just a second. So is my screen visible?
No, it is. Yes, it's coming. I think it's coming. Yes. 3 support.
Yeah, you see it now?
Mm-hmm. Yeah, we
Yeah.
do.
Now I have print this, but the problem is this area at the back. Just a second. This area is starting to do well, but when it start sloping up here, the wall is not closed, the infill enough.
Up there. Yeah. So what you want to do there is that when you are looking at your walls, that you have a little bit more top surface layers. How many top surface layers do you have now for this? This is maybe a little bit more a question that we would do in the slicing class, because this issue is not material related. This is slicing related. Basically, because you can see almost already in your slicing that you can see those lines coming apart in the top parts of your print. And this, what is your infill density that you have? Oh yeah, your sparse infill density is 10, right? So to make it really soft.
Yeah, around 10, yes.
Yeah, so the lower you make your infill, so the lower, also for those of you who are beginners, the lower you set this grid, the density of this grid on the inside, the more, especially if you print vertically like this, we'll talk about that tomorrow, the more walls you usually need to cover that, because of course you have a really open grid on the inside, and then what happens is that as you get to the top, you need more layers. So there you can go up to 5 or 6 walls. So we usually do 2 walls, regular top, and then maybe 3 or 4 top surface layers.
Yeah.
You can also, if it's only in a specific place and not so much in the other places, put a modifier in there. So put a specific other objects. Oh, it's another trick I can show for the advanced people tomorrow. That's not for beginners. And so that only in that area you have that thickness, so that you don't have that thickness necessarily everywhere. Do you have another suggestion, Leila?
Those shell layers are 0, the value 0.
Yeah, the top shell thickness is 0.8 millimeter. Top shell layers are 0 layers. So that's probably one of your problems, because you have 0 top shell layers. So it will go completely open.
Yeah, maybe just 3 or 2 right back.
Yeah, right, 3.
Okay.
And then if you re-slice, you will probably already see a much better closing on the top. This goes relatively fast, so we can remember it.
But it will fit the in the middle also if I change this to 3 layers, because somewhere like this also not close enough.
Okay, so
And-
you can see where indeed in your, also when you make a trial print, you will see immediately where it doesn't close up well. And that's where you can so you either change those settings for the whole model or you need section of, there you go. See, this looks now already completely different on the top, where you saw the such gaps between your lines. And now already it looks much more closed. You will still have to see if it's enough on the top. But this is something that you might have to just try in printing. What you can always do is, instead of having to print the whole shoe, cut off in your 3D design program, just cut the top, print only the top. Just so that you can see, okay, is it correct now before you have to do again the whole shoe, where the rest of the shoe might be just fine, and it's going to cost you a lot of time and material. So,
Yes.
Okay.
yes, does that make sense?
Yeah, makes sense. Thank
Okay.
you. I appreciate
So, any other questions? We can also go more in depth in the slicer class. Before I jump to Nela, because I definitely don't want to miss with the Balena, because Balena has some very specific issues and settings that you have to know about. I want to just remark one thing for everybody, which is, I think, very important to note, and that is the balance between nozzle size and material shore value. So say that, so the general rule of thumb is, the higher your shore value for your material, right? The closer you get to 100. So if you're 95, 98, these are semi-rigid filaments. That's one rule. So, okay, the higher that number, the stiffer your material. However, great influence is the nozzle, because the other rule is the smaller the nozzle, the softer the material will come out. So if you have a relatively stiff filament, but you really want to use that for specific reasons, maybe you just, indeed, in our case, we love the eSun when it's so transparent and all of that, or metallic-y, or other properties. Try, if it's possible, to print it on your 0.4, maybe 0.6 nozzle. So for those of you who are beginners, when we are looking at a nozzle, so the part of the machine where the filament comes out, if you buy a machine standard, it's 0.4 that is in there. And you can change that. So the nozzle start at 0.25. This is actually something that Sonnenfeld is also using on the outside. This is why if you want really fine print quality, super soft like this, you do that. It's beautiful, but also remember, the smaller your nozzle size, the slower it prints, because of course the thinner your layers are. So you can already imagine, if I have a 0.4 nozzle and I go down to a 0.25, that's basically almost doubling my printing time. So this is something you have to keep in mind. So generally, if you're trying to print faster, one of the first things you do is increase nozzle size. So we have in total 0.25, 0.4, 0.6, 0.8, 1.0, 1.2. Those are usually that's usually kind of the range that you will use for filament. I mean, if we go and look at palette printers, there's bigger nozzles also, but generally, so for instance, when I again look at the fused footwear, here you can also see the lines. This is a 1.2 nozzle size, so and he just simply uses the lines as a design element, which you can do because it saves him a ton of time to print in 1.2. So say if you go from your 0.4 nozzle to your 1.2 nozzle, that's 3 times faster. So maybe also for Mitchell, that's a good thing to look at for your barefoot shoe, if you can go bigger nozzle. So because it really cuts down your printing time a lot. So you can play around with that. If you have a material that you really like, but it's slightly soft, we are actually now testing a material, the lilac shoe that we posted today. Somewhere. It's here, the lilac. Yeah, the material, but the shoe, the lilac shoe. Yeah. We are testing a material by Sting 3D. And this is a material that is a 90A shore, but if you print it, so if you heat it, it becomes 75. Yeah, let's try just this one. Quite interesting. So this we actually did with quite a high infill for one of our previous students that wanted to have the shoe printed. I must say, pretty good flexible, but this is a very high density infill. So I think we're now printing one with a much less dense inside. So that's another thing that we will start seeing, more filaments that will come out softer. In some of these, this is also that material, when in some of them, we just felt this is too soft. So what you can then do is either say, okay, I'm going to increase this density, or you say, I'm going to put in a bigger nozzle. If you print on a 0.4, whenever you can do bigger nozzle, it's always my advice, do bigger nozzle, because I mean, that saves a lot of printing time. So that is quite interesting, where I'm like, okay, if you are able to do bigger nozzle, then indeed bigger nozzle and very stiff material leads to quite rigid shoes. But if you start with a more soft material and you can print it big nozzle, then you might end up with an ideal combo. So, but for those of you that are new to printing, as soon as you start printing, you'll start realizing how that works. It just takes a lot of practice, print samples. If you have a new material, before you start printing a full shoe, always make little swatches, always make little cubes, little blocks, try different infill setting before you go through a full shoe, and then you're like, oh, there goes my roll, and this was actually not what I had expected it would be. So any questions before we jump to Nela and to talk a little bit about Balina and for her maybe to show a bit of the project, what she did? No? So, yeah, okay. I'm going to turn to you. I will be assisting you with starting the video. So.
Okay, perfect. Okay, now I want to dip a little bit into Balina. As Nico showed before and mentioned before, this is not only a flexible material, it's also very stretchy. And that's something very important to take into account when talking about materials and materials that is, which is nice because it's fully biocompostable, bio-based, and it's nice in a sustainability way.
It also feels really nice. It's really nice on the skin. Yeah.
That's why I chose it for my project, exactly. But it's very important to understand that the smaller the nozzle you go, the size you go, the softer it will come, or it just won't come out.
Yeah, it's basically the smaller nozzle you go, the bigger the chance it is not going to come out. Yeah,
it's a bigger challenge because the nozzle closes. Yeah. That's also very important to understand. And it's that with Balina, we have this issue because Balina is not only flexible, it's very stretchy. So you can see this, I'm pulling out, and it pulls out perfectly, and I can keep pulling out.
Yeah.
So
one of our students, Eric, did a test in a tensile strength test in school on one of those official machines, and it just could go and go and go, and it did not break.
Exactly.
Which technically is good from a quality perspective, but from a print perspective, could be a little bit of a nightmare. So
exactly. Actually, the minimum nozzle size advisable for this one is a 0.6. And we, precisely with Eric, we face many challenges because for my project, which I'm gonna talk about, I printed a textile basically. So my project is a bra that completely is from body scan and it adapts to your body. So for me, it was very important the softness of the material. And one big complaint we have in the industry around TPU is that it's very tough on the skin sometimes. And of course, if we then go to Balina, this is a very soft material. It feels incredibly nice on the skin. And here you can see a little bit of the bra and how it's printed. It's a fully printed garment.
A bit close maybe to the, you can see. So this is a fully printed garment. This is what we call an auxetic texture so that it stretches.
Adjust to your body, exactly.
And so for those of you that are in our textile printing courses, this is also interesting to see different connections, different densities. This is a double layer.
And I must say that the biggest challenge I had with the whole project was printing. It was printing and making it coming out of the nozzle. I had to develop a workflow where I was basically just using, because to get like this level of detail, you need to have like a very, very, very the smaller nozzle size that it was possible, that it was 0.6.
Yeah.
But as you can see, this was maximum 3 for layers.
Yeah.
So it prints. But with Eric, we face a challenge that is that above a certain normal, because he was printing a shoe. So of course you need even 1,000 layers.
Yeah,
so,
I cannot show you that shoe yet. We're going to do actually a separate class on it because this is one of our students who graduated with us on a system of how do you minimize your material in your shoe and optimize your printing time. His best experience is on Balina, 1.2 nozzle, for sure, hands down. Yeah.
I could print 3-4 layers perfectly with Balina for my bra. It works fine. It fits very smooth. It's also skin safe. That's also a big quality, a huge quality about the filament. But Eric started printing with that material for the shoe. It stopped printing at a certain height. So the higher the nozzle size, it was the best.
Yeah.
For the
Otherwise,
for this
simply
material.
what you have is the same as with other very soft materials. The pressure just starts building up because it keeps pulling and pulling and pulling, and the filament just stretches and stretches and stretches instead of going down. And that's when at one point it just stops extruding because it doesn't get enough either. Usually both things happen. So first you don't get enough extrusion, and then suddenly the tension breaks, and then it shoots out of your gears. So you experienced printers probably have seen this. You have the gears that pull the nozzle in, and it shoots out of it. There's a big loop coming out, which you don't want.
Yes, and also something I developed a workflow where it was basically for every time I was printing, because of course I couldn't print the whole bra in one bit. Basically what I did is after each print, I immediately had to run to the printer, take the material out, and then hit the nozzle extruder again, and then pass some PLA to clean the way, so I could pass the ballina again.
Yeah.
And this was, of course, because I needed the detail, because it was the smallest nozzle size. But if you go for a 1.2, then it's, of course,
It's
better.
a little bit easier, but still advisable for those of you that want to print either with the ballina or in general with a very, very soft one, but especially with the ballina. As soon as you print, take the material out. Even if you want to make another, so even if you want to make another print, but you first need to slice or you want to try some other things or whatever, take it out. And indeed, and that's a general good one anyway for cleaning the nozzle. Could either be with depends on what you have inside. So if you are printing with a material that's very high temperature and it might be clogged, you could put maybe another high temperature material in there, a more rigid one like a PET. Otherwise, indeed, you could do PLA and you simply jam it by hand through the nozzle.
And it was very interesting to see all the clogs coming out, even though it wasn't clog. So it was already like forming inside.
Yeah.
And that was basically, you had to keep taking the material out. Even if you say, oh, it's only 5 minutes, I certainly don't advise that.
Because if you did not do that, after that, you basically needed to physically take your nozzle out and clean it and disassemble your print head.
It's very funny that Nico, when you introduce me, you say, you have to be patient when working with these kind of materials, and also you have to like and enjoy to open your printers. It's the beauty. It's where the fun is. Because I literally would see like knots inside of the gears with ballina. And was like, okay, I had to open the extruder like 4 times. And then I was like, okay, now I understand how it works. But definitely it's about patience and trying. And with ballina, I would advise go for big nozzle size.
Yes, exactly. And you should still enjoy taking your printer apart. It will happen. It's just expectation management also for people who are new.
Yes.
It is true that sometimes it seems, of course, because everybody, that's why we also try with Footology at least to also post our failed prints where you're like, because of course for Instagram, everybody would like to show, ta-da, they're pretty ones. And so then the downside of that is that people who are new and have seen that come into courses and go like, wow, this printing is so easy. It's just you load your file, print, and it's coming out perfect. And then have to go through the rounds of disappointment when you have failed prints, because you will have them. And that's one of the things that we train for a lot in the courses, also in the courses here in the lab. To really prepare people for troubleshooting. And as much as we say, okay, people come in here and want to, of course, get a really nice print out of it and are disappointed sometimes if they don't have the perfect print by the end of the week. But I always say, better to have everything go wrong here, where you have support that can tell you, this might be wrong. We have to change. This setting we have to change. Because otherwise you think that it's super easy. You go back home, you buy a new printer and it's different where you are. And you simply have no idea how this is going. So this is definitely something that I would advise for people to be prepared for if you are new to printing, that you have to, make your hours and
Accept failure.
accept failure as part of the process. And also there's a lot of things that happen in failure where you're like, oh, I didn't actually think of that. And then it suddenly creates you something support in some area where you were like, I don't think that, but that actually was cool. So, I mean, there's so many different things that can happen in failure that are also fun, or at least teach you a lot about your printer and material printer combination. So, are there anything you want to add?
Yes, I would also love to add about Balina, and is that it is a very nice material, but it's very slow to print. I would advise maximum 15 millimeters per second. 15.
Oh, 15, and that's indeed for those of you that know
That's
about
slow.
printing is slow.
It's slow.
So you think about, so say on average, when we are looking at a Filaflex, we usually are anywhere between 25 and 40 millimeters a second. On a Delta printer, which is the ones with the 3 rods, essentially, that could be a bit faster because we don't have the moving bed, but not all that much faster. So then going for a Balena 15 millimeters a second, where you have to understand that for a PLA, it's easily 200 or in the hundreds of millimeters per second. Of course, that difference is high. And that's also why for flexible, it's so important to look at how can we increase speed? How can we increase speed? Can we print faster? Can we have the filament a bit stiffer? Can we have the nozzle larger? Can we have the shoe more simple? How can we increase the speed? Especially for those of you that have the aim of being able to produce your product, because and the more material that's in it, the longer it takes to print, the more expensive it is.
And how to combine materials. You basically can have the outsole completely in Balena and just a few layers, and then on top you can put another material.
Definitely. If you print horizontal, so tomorrow when we go into the design class, we will talk about, do I print my shoe like this, or do I print my shoe like this? Both are possible, just for different shoes and for different reasons, and we'll do that tomorrow. If you print horizontal, of course, then you are able to do what Nela says, start with layer Balena, and then on top some other layers of other material. Imad, tell me, you have a question.
Yes, hi. The Google Drive, there's no files just to practice on. I mean, I'm not sure if you managed to put some files on the Google Drive.
Yes, good that you bring that up, by the way, because the strange thing is there has been a change in our backside. So that's not us, that's the platform called LearnWorlds that we run on. And indeed, the link for the Google Drive is no longer working. And I tried to restore it today and it doesn't want to open. So now I have asked the help desk for a different way to be able to get you the files, because we have a whole bunch of files for shoes that you can try as a trial print.
Email would work, like an email. Email.
We could do it via email to make a WeTransfer link, maybe that I share. But I think it's handier if people see it in the. What I'm trying now is to see if I can use a WeTransfer link inside because I can put a link inside the school, and I'm now going to try if it could be a WeTransfer link. Because it's also fine. I mean, those you are welcome to download. So please expect that tomorrow that will be fixed, because that is indeed a hurdle that we did not have before, and now suddenly that drive doesn't work anymore. So that's the thing.
Thank you.
Mitch, you're welcome. Mitch, you also had a question.
Hi, yes. Can I ask, for the bra and for shoes in general, do you recommend going with Rhino all the time? Because I know there's so many different kinds of software out there. What do you think?
But our general rule of thumb, the reason why we do a lot of Rhino is because it's very exact. I mean, it doesn't mean that it's for sure, doesn't mean it's the only one. We also do a lot of Blender. We also have people that do Gravity Sketch. It's just that Gravity Sketch is a little bit more known to not necessarily create meshes that are fully closed, but it's also getting better and better. So my general rule of thumb is use the one that is easiest for you, that you find most intuitive. But if you want to go for production and you need to be quite exact, or you want to work with generative systems with grading and stuff, then I definitely do advise Rhino because it's a little bit more exact. We have here upstairs a Soul, which is almost like a boat, which was funny, which was for one of our students who works in Blender. Blender is a mesh-based and not a surface-based. For those of you who are modeling, you know the difference. A system, so it means that it's less exact in how large it's basically you could say that a Blender is like the Photoshop of the 3D software, and then a Rhino would be the Illustrator in terms of how it operates and how exact. So she had made something in Blender, not looking at what actual size is that, and then she took it into the slicer, and also not looking there what size is that. And she was like, no, I'm sure this is perfect. I made it in Blender exactly to the size. I was like, it's a 50-hour print just for a Soul. This is a bit much. And she was like, no, and it's literally maybe in the design class tomorrow we can show it. It's like so it's like it's really funny. I show it as an example of what. Because it was like, yeah, I don't know what person you are making this for, but this is an absolute giant with a size 55 or something. It's so that's why, but both work. It really also depends on what you want. I mean, we have a couple of really experienced modelers here. Diego, do you have any suggestions there? I know that you also have a lot of experience.
I would say that, yeah, well, depending on your level of expertise on the technical aspect of woodwork, and maybe also on PET, maybe you can start with Rhino. But if you're not so experienced in that and you just want to try, why don't you try just with Blender? But why not maybe with I don't know, ZBrush, for example, for iPad,
Yeah.
or Nomad
Yeah.
sculpting. I use 3D sculpting software a lot.
Yeah.
Yeah, if you want to make just a block, start with a shape and start pulling and pushing, maybe that's a good one. That's another one.
Yeah.
And if you have the possibility, for example, to tackle on non-destructive workflows, let's say, of course, Grasshopper, but also maybe Substance Modeler, that's another great one, to try.
Yeah.
Okay, thank you.
Yeah, once you go down that rabbit hole,
Yeah.
but indeed, it is true that also I do agree very much with what Diego says, especially if you're a beginner. Of course, also the price of the software there is a big denominator. So indeed, of course, Blender is a free software. So I can totally understand that a lot of people start there, and that's absolutely fine. And it has become better and better and better. And there's a lot of different tutorials that you can follow on that. So I could imagine, yeah, starting there and then going into the more exact ones.
Great, thank you.
Yeah. Anything she wants to add here?
I want to add
Yeah.
about drying.
Oh yeah, we almost forgot that.
Yes, very important, drying.
Yes, drying. So I'm going to take you for a walk through. Yeah, I already forgot in my own class to talk about drying because we. So if you want to print well with a TPU, that's the final thing I do want to say because we're going a little bit over time. Yeah, but now behind me, maybe now behind me you can see. Let me see. I don't know if you can see our view because we're right directly at the ocean. I don't know if you can see that. Should you come to our new lab, it's right at the sea, really nice, or at the beach. So let me see. Down. Am I in the image here? Down here? Yes, you can see it. Hold on. Oh, let me see. I have a menu on my screen that I don't need. Hold on. Here, there's a dryer. You see that? Yeah, this is a dryer. And we have down here another dryer. So there's a lot of different options here. I'm going to move back to my table to explain what this is. So TPU has the downside that it takes in a lot of moisture. And you don't want that because the wetter your filament is, the worse it prints. So you can always recognize if you are printing and your filament's too wet, you hear like almost like little bubbles of water evaporating. That sound you don't want to hear. And you will also then see, I can probably show it tomorrow when we look at the big saw, because it has that issue, that it looks irregular. So what's advisable, a lot of the filament suppliers also mention it, especially Recreus has a lot of good information on their website for that, is that you dry at least 24 hours. And what you then want, it's usually somewhere around between 50 and 60 degrees Celsius. And what you want, you will see a percentage on your dryer of humidity. You want it to get as close as possible, or maybe under 20. In very humid areas, sometimes a bit more difficult. But in our case, we also cheat sometimes a little bit. If I don't have time or I forgot to prepare, because it asks for planning and preparation, like, oh, I have to first do 24-hour dry before I can start my print, is that sometimes I just do for 1 or 2 hours and on higher temperature, on 60, 65. Does work, but it depends on sometimes a little bit on what filament. On the other hand, there's some more hard filaments, so the ones from eSun that we showed, we hardly have to dry at all because it's not a porous filament. It feels also much more stiff and smooth. So, but definitely things like foamy, Filaflex, you have to dry. And sometimes if things are really irregular, that's the first thing that you want to look at. So dryers are not expensive at all. You have them from 25 euros onwards. The 2 different ones that I just showed you, one is a really simple one with 2 rolls, and the other one is actually technically not an official filament dryer, but it's a good tip for those of you that want something that works well and is not expensive. It's a dehydrator. So if you look for a dehydrator online that you use for dehydrating fruits and stuff, like in the kitchen, because those are also like little ovens, essentially, that can heat usually up to like 50 degrees, and that's kind of what we need. And they're a bit bigger, usually. So we have those because we dry pellets, because for pellets you also need to dry, and we dry filaments. Another option, which is what Recreus does themselves, is that you put all your filaments in a closed cabinet. We don't do that because for us it's easier to see quickly what we have. But ideally, you could put all your filaments in a closed cabinet and then put indeed a dehydrator like you would have in your house in there. So you have these dehydration devices you put in your house if you are in a very humid climate. So if you have large quantities of filament that you essentially want to have ready at all times for printing, then it's advisable to do that. Get a really big closed cabinet and put a dehydration machine on the inside. And that is also a good tip. It's something that I want to prepare for later in the year, to have a filament closet that's always ready, because now the way we have it, since we have them, also you can see behind me the piles of filament out in the open. But it's, for us, it's a bit quicker also, since we work with so many people, that you can see what you have. But indeed, we do have to dry more because we have the filaments out. So you can also maybe wrap your filaments in plastic. All that will help, but you will still have to dry. So, any other questions before we close out for today? Brian, tell me.
Hi, Nicolene. I'm Brian from the San Francisco Bay Area.
Hi, Brian.
I had a question about what are the latest materials that you've been seeing in industry for 3D printed shoes, and also kind of like what do you see on the horizon as the next materials?
Yeah, I think the Sting 3D that we have been looking at today is one of the things indeed that are new. So this is more the principle of a high shore value because of ease of printing. So a 90A stiffness in the filament, but a chemical reaction due to the heat that makes the end result softer. This is definitely something that we see. In general, if you ask me in general about materials, then the movement for sure is towards more bio-based, but this is happening first in the rigid and then in flexible, because the problem is that the weakeners that make a material flexible are also usually the chemicals that are not compostable. So that is one of the difficulties. Other thing in general, but goes slow, but this has to do with the building of machines, is that I think that we will eventually see the full transition of filament towards pellets. Because it's actually quite strange that so any plastic starts out as pellets like this, then it's extruded into a filament and then sold to us. So it's much better if you don't have that. And also in our case, since you want to have maybe different material mixtures, you want to have, say that I want to combine, I don't know, this is like an uncolored pellet, and I want to combine with different colors of pigment, for instance, or we talked about, for instance, foaming, where instead of saying, okay, I don't want to have the full shoe out of a foaming material, I just want to be able to say, okay, from this layer to this layer, I want you to add a foaming agent, and from that layer to that layer, not. So we will start seeing, those are not on the market, but there is for the, we're going to have a scoop actually for today. For those of you that are coming to Footwearize, there's a new print farm starting in the Netherlands called Indie Digital. They don't even have a website yet. They are fully pellet based, and they have indeed pellet printers with different canisters, combining different pellets in a print. They do. They come from the orthopedic industry and now moving into non-orthopedic, and they come and explain what they do. And they indeed make anything from lasts to molds to wearable shoes, so from soft to very rigid. So, as a material concept, that's generally what I'm thinking of. Tomorrow we will have Federico, a really good Argentinian designer that just literally stumbled into our lab in Barcelona to show his stuff. He makes great stuff. He uses Flex PLA, which is one of those other materials that is quite rigid and comes out flex. I have used Flex PLA ages ago, but it was very rigid, and his is not. And this is a brand called Print A Lot, easy to remember, Print A Lot, and that's another example of relatively stiff filament that comes out soft. I think those two things or three things are the main things. So compostable, biodegradable, stiff filament that comes out soft and lightweight, and general shift towards full-on pellet. That would be my reply to that.
Awesome. Yeah,
Does
thanks
that help?
for that. Yeah, thanks for that reply. And just a small second question. I'm new to the footwearology community, so this has been a great class. What's a good way to stay, I don't know, communicating with the community moving forward? Is it through like social media or email or what?
Yeah, so I mean, this is our first like community event where we're like, oh, let's get everybody together to talk about printing. We had a Discord channel briefly, but I must say that there were not many people on there, and it took us a lot of work to do that. So if you are in a course, you can always place questions on the discussion board. So as soon as you click on if you're in a course and you load the videos, you will see like different tabs on the left-hand side. One of them is called discussion, and there you can leave comments, and that's a great way to connect with community. But I think the best thing will be indeed in live sessions like this. And we've been experimenting with different things in the last months in terms of live classes. I think what we will start doing is to offer more and more courses that are pre-recorded so that people can watch at their own pace. But then, for instance, have weekly or bi-weekly, depending on how many people join, sessions like this, where people can say, hey, listen, I'm stuck, I'm doing this or that. And then indeed combine it from different courses, because everybody can learn from different things that everybody's doing. So that's coming, where we're starting to do more question hours like this.
Got it. Thank you.
Yep. All right. Mitch, another question.
Yes, you mentioned courses, Nick, and so I saw that you have some legacy courses, and then you also have some new courses coming out. And so I'm trying to decide where to spend my money. What am I gonna like gain going with the new courses versus the legacy courses?
Yeah, so the legacy has to do with two things. So on the one hand, the legacy has to do with Rhino. Rhino has shifted last year from 7 to 8, or actually already the year before. We are actually quite late with making our Rhino 8 course, but we've been extremely busy. That Rhino 8 course is starting in September. And we have taken the opportunity to change the format of the course a little bit. so that it connects better to all the other things that we do. So what we have coming and as a new course in Rhino is that it's going to be in separate modules, so that people, instead of having to do everything at once, can say, okay, I'm going to start here, first learn this. So the first module is going to be about making a printable shoe, because I know that's a lot of people that want that. That would probably be also a modular shoe. And then from there, we go into different modules that have different purposes. So there will be a module, for instance, for building lasts. We know that there's a lot of people that want to do that. There will probably be a model for making heels. And we want to connect our Rhino a little bit better to the other courses that we have, because footwearology is about footwear innovation. How can we make stuff locally? How can we make stuff automated? Part of that is printing, not everything, because we also do a lot for molding and for knitting, but we want to make that connection better. Now, the legacy courses are interesting in the sense that it's essentially all the different functions of Rhino. It's just Rhino 7. So there's a few minor things, not even huge things, that are different, that are not there yet because it's not in. Yeah, something like shrink wrap. That's an easy way of modeling that is not available in 7. And the format is a little bit different because in this Rhino course we have a bit more traditional format of, okay, build a last, build an upper, build a sole, which is a little bit more geared towards traditional footwear manufacturing, and we have more and more people in our courses that are printing shoes. Then from the other side, there's the Making the Future Footwear course that I teach. This is about footwear technology innovation in general, in terms of making of shoes. And there's so many new technologies now on the market since I made that course, because that was one of the first ones we made, that needs updating. So all the technologies that are in there are still fully relevant, and for the average factory, actually still quite innovative. But when we're talking about actual more, cutting edge footwear innovation, there's many more technologies now that I not have available when I made that course. So that's what we have in new courses. And there's also a big new course that I'm preparing, which is bringing together a lot of different things, which is essentially about how to design footwear for the future. And that is very much based around how do we design things that meet all the eco-design requirements? How can we design things that have multiple lifetimes? How can we design things that can be easier recycled? How can we maybe use even existing footwear? So it's really that course is going to combine everything that I teach in a lot of in-person courses here or in company courses on future design. It's a lot of different ways of design thinking. So all that's coming. But the legacy courses have the older version of Rhino, and connected to that, Grasshopper and Sub-D modeling, which are both parts of Rhino. But since we are innovating the Rhino, we're essentially phasing them all out. But I must say, since they're now so cheap, it's still a fantastic deal. So for me, I'd say go for both, because it's essentially nearly for free. I think that we are now offering those courses. So because they're quite elaborate courses and also quite specialized things in there, all for footwear. So I think it's a great deal.
Sure, it sounds exciting with all the new stuff too. Please tell me, when do you expect pricing to come out for the new stuff?
Well, the pricing for the new stuff comes out by the end of the month, because we are stopping the legacy courses on August 31st. So anybody who is interested in those special offers, enroll before August 31st, because then I'm closing enrollment for good. You still have a full year access to those courses, so that's still fine. And also by that time, I will have the curriculum and prices for the new courses up. But that's what I'm working on now in this month. That is a little bit more holiday in the south of Europe. So then I have a bit of time to work on stuff like that. So that's going to be launching by the end of the month. And the courses itself are going to be starting from mid-September to later in the year, but the announcements will start happening by the end of this month.
Great. Thank you very much.
Okay, you're welcome. Anybody else any questions before we jump out?
Yeah, what's the breathability of like TPU? Is that something we need to account for as we design?
Yeah,
whether it's
in the design.
a sneaker or a bra?
In the design. So essentially what you want to do if you want to make it breathable, is to make it open. So this is also why, for instance, if we're looking at the for instance here again, seller cultures, but we can also print with that. This simply means a lot of people, we will see that in the slicing class. A lot of people are like, oh, how do you do these textures? This has, okay, the general shape of the textures is 3D modeled, but the fact that you see this open, almost knit-like structure has nothing to do with actually 3D modeling. This is in the slicer, simply means that we make no walls so that we don't make this closed off. And this here you can see indeed in this one, you can see the difference between this is what we call walled, which is solid, and this is what we call open walled, which has no wall, which the structure is done by the slicer. This is breathable. This is not. Or what you can do, it's just simple after processing or in the print. Let me see. Oh yeah, as you can see here, this is also from Fused. They just incorporate holes in their design.
I see.
And that's a very simple way of breathability, but there's no chemical breathability to TPU. So that's something that you do have to understand. So if you want to have breathability, you add that by making textile-like structures. So that's why I could say, for instance, what you wanted to do maybe with a leather upper and then indeed the gyroid sole. Of course, that is very breathable because it's very open. So, and then you kind of have the best of both worlds. So you can definitely do that. Fuse has also done that. They've made really nice leather upper shoes with printed soles. And yeah, there's no reason at all why everything should be fully printed. So I always encourage people to experiment with the different methods. So it would be great to see what you make if you have something finished.
Yeah, I'll keep you posted. Yeah.
Perfect.
Thank you.
All right. Well, guys, we are really now almost half an hour over time. For some of you, it will be very late. I know Retha is in Thailand, and we have people from the US, and by now the Australians could start joining. Everybody was like, too early for me. Can you record it? So, but it's at least great that we have everybody from all corners of the world joining. So thank you guys so much for joining today. Tomorrow, we are going to look at the design of shoes, and we're going to be in depth into if I want to start designing a shoe for easy printing, how do I do that? And that's, I think, one of the best things to learn, and also very suitable also if you are new to printing. If you don't know a lot yet, this is actually the thing that you need to start with, because it will open your brain to how do I design to create a shoe that I can actually print easily. And I think that's an important one. Yeah. All right then. So you guys all have the links, and yeah, it'd be great to see you guys tomorrow again. If there's a design that you want to share, or where you're like, oh, I'm running into an issue and I don't understand why is this or that, you can also send this to us ahead of time, so that we can have already a look and then give a response live in the class. Yeah. All right.
Thank you.
Thanks, guys.
Thank you.
Much.
Bye.
Bye.
Thank you. Bye-bye.